Hi everyone, good morning, good afternoon, good day wherever you are. I hope you can all hear and see me okay. I'm on my own today, there's no Spencer or Paolo, they've both left me, they're both on holiday today, so it's just me. How's everyone doing? I hope you're all okay. I hope I haven't thrown anyone too much with the time change this week. I see Eal joined at the normal time of 2 o'clock, but we'd slightly moved it back this week. So how's everyone doing? Everyone doing okay? What has everyone been making or designing this week? I hope you're looking forward to the Christmas challenge that we've got going on today. So yeah, so for those of you that haven't joined the live stream before, if this might be your first one, my name is Richard Stubley. I am an Autodesk employee, I'm a process specialist. I work out of the Birmingham, UK office where we've got this massive technology centre. Tell you what, as it's quiet, let me pick up this camera and let me just give you a pan around the workshop for anyone that has never been here before. So, those of you that don't know, the Hass is where I normally live, which we've got back there. We've got a Doosan lathe just here, which I do some lathe work on occasionally. So, if you want to see a bit more lathe work, give me a shout and we can feature that. We've got a big DMU over there, and then we can look down the shop and we've got a couple more machines down there as well. So, lots of machines, lots of nice bits of kit. And we use it all to make sure that the software that we're creating is fit for function, that works as we expect it to. And also we do customer projects here as well. So customers might come to us with a problem, and then we work with them. We get the software solutions, and we test out everything. We actually, maybe make the trial parts to prove that everything works okay. We've got people from New York. I'm going to murder your name. I'm sorry, but I'm really sorry if I pronounced that wrong, but welcome. I haven't seen your name before, but I normally don't do the chat, so I might have just missed it. But welcome if this is your first live stream. So yeah, if you don't know, this is the Birmingham Technology Centre. There's lots of technology centres all over the world, all doing very similar things. We can't produce software if we don't use it ourselves. And the team that I sort of live in, that's pretty much what we do. We make sure that we are almost like a customer inside of Autodesk. So we try the software, we use it every day, we make sure that it's doing what it should do. So yeah, right. That's the timer up. Everyone's hopefully joined now who's going to join. Thanks very much, everyone. Let's get straight into this. So, what we've got now is this is the Christmas Challenge live machining event. So, thanks to everyone who have entered the Christmas Challenge. Here are just a few. I'm just realising I'm hiding some of the ones there. So let me move myself. Let me just get rid of myself. That's a lot easier. So yeah, brilliant. Thanks for the entries, everyone. Really appreciate everyone entering. It was just a bit of fun. I thought, let's try and get everyone together. Let's try and make some different parts. Some really nice entries. Those of you might have remembered the focus of this was design for manufacture. So it was all about designing a part that could be made. I absolutely love the angel design, but I'm not a skilled enough machinist to even attempt machining that. I'm sure some of the people in the workshop who actually do this properly as a job, run the machines, would have been able to do that, but that was well out of my reach. But yeah, really liked all the designs, some really nice ideas. The bottom right corner, the character from the Grinch was actually made. The guy, I can't remember his name now, 3D printed it and painted it. Really nice touch there, using the F as the antlers. Again, really well done to everyone. It was brilliant fun for me watching the designs come in. So I chose one of them what I thought I could machine live here for you today. I'm not saying it was the best design, it was just basically one that I thought would work well on the live stream. And that is the bottom left one, so the reindeer with the F as the antlers. That was what I chose. Again, I just thought that was going to be the easiest one for me to machine. Again, the focus of this was design for manufacture. So when I was looking at this, I was thinking about how can we fixture the parts. So let's jump into Fusion and let's quickly see sort of how I did this, how I went about it, and how I made it. I mean, I'm not lying, everyone. Here we go. We have made it. I made it this morning. I've made 2 of them now, and then we'll be working through some of the options or some of the operations on this live stream today. So again, we did make it. We weren't just kidding. So let's have a quick look inside of Fusion, what we did. So I had to have a look at this part and think, how was I going to make it? And that was why I chose this part, because Again, you might have seen those of you that entered, I said what tools that I'd got available. I'd got 2mm tools, really, that was the smallest I was willing to go. But, you know, I don't want to have to do a 2mm across the whole part. So I chose this part because I knew I could actually go with a 4mm tool looking at this. That was the smallest end mill I had to go down to. So really what I was looking at there is the gaps between sort of here and here, there and there, and then that lower bit and that lower bit there. I needed to make sure that I could get a 4mm tool in, like what we see here, to actually go around that portion there. Again, if that little bit there means that it's lower than 4mm, it gives me a lot of problems how to put other tools in. So this is big considerations of when you're designing your parts. Look at the gaps that tools have to fit through, and make sure that those gaps are actually large enough to get your tools in. It's not necessarily about the minimum radius. You know, you could have had a radius in there of 2mm. Radius of 2 means a diameter of 4. But then if this gap here was less than 4, I've still got to go in with a smaller tool. So really important things you think about when you're designing your parts. Think of the minimum tools you want to use and go from there. Again, fixturing, how was I going to hold this? So when I looked at the video of how this was made, I noticed that it had a flat back to it. So I thought, brilliant, I could use our chuck on our machine and have it gripping externally rather than gripping internally, and I could hold the part that way. So that was exactly what I did. So I used the chuck on our machine, I grabbed the inside, pulled the jaws out, and machined it that way. So we can sort of see on the camera there, the flat back. So I put the jaws in, expanded those jaws and held the part. So for operation 10, let's have a quick look at what ops I did for that. Really simple, really nice and easy. Let's quickly go. So we faced off the component, as you'd expect. I tend to do 1/2 mil step down on a saw cut billet. Again, I don't want to waste material here. So 1/2 mil is normally enough with our saw. It's quite accurate, so 1/2 mil is about right for what we're doing. If you're cutting these with a hacksaw by hand, you'll probably need to increase that up just to take off any of that deviation from the surface. Again, little helix path on there. I could have probably gone a bit higher on the ramp angle, but I was just being a bit conservative. And then, as you can see, machining out the pockets from there. So machined out the pocket, left a little bit of stock to leave on the side, which you can see with that colorization, and then went in with a finishing one where I finished the floor and finished the side walls there. So that was my Op 10. Just really simple, all I could think of just to give myself the features from that side that I couldn't get to from the other side, and then the location points for me to datum off for our operation 20. You see each run I chamfer pass around. Again, chamfer your parts, everyone. If you're making parts, chamfer them. It's so easy to do. Chamfer tool infusion is really nice. It detects collisions. It's what we call model aware. So again, makes lovely chamfers on the part. So that was what I was left with for my Op 10. So we can see that's what I've got here. Let's just quickly flip to a larger view there. That was what I ended up with. So faced it all off, machined the pockets out, and then put a nice little chamfer on the edge there. So I went from a little bit heavy, I went from my raw saw cut billet to my Op 10. That was the first set of operations that I did there. So again, hope everyone's enjoying this. Let me know how it's going. I've normally got Spencer or Paolo helping me out in the chat, but it's just me today. So that was my Op 10. So all I did then is I flipped that over and I then gripped it externally. Sorry, internally. Gripped it internally. So I started off with the chuck holding on the outside of the part. I then flipped it over and then held it internally and expanded. So interesting thing on there you've got to be careful of when you're using your chuck. If you are gripping internally and expanding out, when you normally tighten the chuck up, that's actually to undo it. So just make sure that you're going the right way on the chuck. So here we go. Let's jump back into Fusion. So again, Op 10, did all those operations. I then went on to my Setup 2. So the next biggest thing on my list is thinking about datuming. I've got to make sure that I don't get any mismatch on this part. So that bore that I machined and that face that I machined, I'm going to have to use those as my datums. You know, I machine my datums first, and then I use them again and again and again. That's how I tend to work when I machine components. So we can look here that my setup, let's actually go and edit that setup. I use the really nice from preceding setup. So that's a really nice tool that you can quickly just make sure the stock's the same size from one or the other, and you've got the same offsets in there. Whereas if I'd gone a fixed size cylinder, I'd have had to have remembered the size of the cylinder and the offset and how I'd gone on there. So I've got to make sure that I get it exactly right from op1 to op2. From preceding setup is a really nice feature that does that for us. And then what I've done now is I've gone selected point as my datum. So we can see that my datum actually, if we just press there, we can see that that face there that I've selected is where the triad is. So again, I actually managed to select that arc. So let's do that again. We've got selected point. I selected that arc, and that put it perfectly where I wanted it to be. If there wasn't the geometry there that I needed, I would have gone into the design workspace. I'd have sketched either a circle or just put a point, and then I'd have used that as my selected point for my datum. So that's what I'd gone through there. And then one last thing to highlight actually is I've got quite a few bodies in this design file. So I've got some of the Fusion Fs that we use for sort of the design purpose, and then I've got a body that I want to talk about later, which you can see there turning on and off. It's actually all around the part, but we'll discuss that in a second. But all I did for my body was just chose the main body of the part, so what we see there, body 2. Thank you. So we've got a couple of questions here. ER's got one off topic. When defining a new tool, what would you use as the tool holder definition for a machine that uses an ER16? So there are lots of different lengths, of course, and geometry that you're going to have to be looking at. Let's just make a new tool now. Let's go into my documents. Let's make a new tool. Let's make a ball nose end mill. In my holder, so what you've got all of these different types of holders. You've got to sort of work out which one of these holders is actually going to sort of be the most representative of what you've got. So the BT30, of course, that's what we call the back end. That's the bit that goes into the machine. And then you've got different sizes on there as well. Again, these are just a couple of standard sizes. You've got like a drill chuck on there. What I would try and do is if you can't find one of these on here that actually is representative of your machine, I would potentially look at modelling up your own. You can model up your own. You can then save that. So let's actually have a look at this again. So you can model up your own holder. You could then save that, and you could keep calling that again and again and again throughout sort of the life of what you're using Fusion for. So if you can't find one of the defaults, you've got to have a quick look at modelling up your own. Again, it's not too difficult. In the tool library, you just want to be able to go into your holders. Let's just go on here and go for my setup 1, documents. Trying to find where I have got, I'm sure I've got one somewhere around here, but I can't quite remember where I've got one. Yeah, I'm not sure I've got mine. I've modelled up all the holders you can see here. These are ER32 holders. That's an ER or an SK16, that might even be, I'm not sure. But spend the time, model up your holders, it's definitely worth it. Sorry, there's not a place where we can download the file. I will ask the guy who designed this if he doesn't mind sharing it out. He can put it on GrabCAD or something like that. It's not my design to share, so I'll ask the question. Thanks very much for asking, though. So again, here we've got the component we've got there. We know our datum is set to that face. So on the machine, I'm going to use my probe, and I'm going to probe the top of my jaw. And then the jaw is going to rest on that there. So again, this was internal, and then it expanded to clamp. So all I did simply was, in the design world, I created a sketch, made a circle. It was an 80mm inside diameter. Extruded that up. Let's go for 30mm. And then in manufacture now, all I did was I just created a 2D contour on that edge, I used my 10mm end mill to rough out my jaws, because what I've got on the machine is called soft jaws. You'll see in a minute what I've got in a minute on the machine. If we go heights, we're going to go down. I went down 9mm, and I'll explain why in a second. And then I did some roughing passes, and I think I did about 5 or 6. So you can see this was just my program to rough out my soft jaws. So you see how simple that was. And then let's have a look why I came to those numbers. So we have a look here, and we inspect there. We can see that's 80mm. That's where the 80mm came from. If I go from there to there, we can see that was 7.5. So I went 9mm just to give myself plenty of clearance. So what I ended up with was my soft jaws were milled, so they were in the form of an 80mm. Of course, that gives me really nice contact points when I'm gripping on the inside. You know, I want to make sure that I get a really nice grip on the inside there as well. So that was brilliant. What we've got now is we've got all our operations. Let's have a quick look at the strategies that we used to machine this. So I used my face mill. I went down with the face mill. Let's have a quick look at the parameters that we used in there. So I used 3mm step down. Normally with our face mill that I use in the house, I do 6mm, but that's when we normally got a lot more gripping force on our component. Whereas, you know, I've only got a few contact points on that edge, and you saw it was only 7.5mm of contact. I put a 1mm chamfer on there, 6.5mm. It's not a lot of surface area really to contact with. So I just dropped my step down. People ask me, can you tell me what speeds and feeds to use? Well, no, I can't, because speeds and feeds are subjective of so many things. The way I normally think about speeds and feeds is you've got to, first of all, have a look at how hard you can hit that part. And that's going to be normally, depending on what kind of machine you've got, is either going to be your work holding. Either the work holding is going to give way, the tool will snap, or the motor will give way. Those are like the 3 things that normally are going to give way, and it just depends on your machine here, on what you've got. Again, we're using solid tungsten carbide tooling. We've got a, I'm guessing 7.5 horsepower motor. I'm not quite sure, but that does ring a bell. And we've got decent work holding. You know, we've got a complete complement of Lang work holding, but on this case, it's soft jaws. Doesn't matter how much you spend on your vise. If you've only got a small bit of contact area, you're not going to have a lot of grip. So the order sort of I'm going to work down in now is, I know that the motor's not going to give way. 7.5 horsepower is going to be plenty. So that's the bottom of my list. Tungsten carbide tooling versus my work holding. I reckon actually the work holding will give way before the tooling on this job. So that's how I now look at my speeds and feeds. I know that the weakest part of my link is going to be my work holding. And that's why I've had to drop my step down from what I normally do to compensate for that. There's a nice thing here called use even step downs. If I just hit OK and we have a look there, you can see all of these passes, 1, 2, 3 and 4 are nice and even going down. That's no coincidence. If we use even step downs, let's untick that, you'll see now that you've actually got, it's quite difficult to see, but there's a bigger step down between those two. And that's because it's trying to spread it out, and then it just sort of comes to an approximation at the end and goes, and then I just have to fill in the gap. Whereas if you use even step downs, what that will do is make sure that, you know, if it was going to be 3mm, 3mm and 2mm, it's going to put it at 2.3, 2.3 and 2.3. So really nice, tick the box. You can even actually make that your default, that's fine. Top tip for anyone now, if you right click, you can make integers to default or strings. You can't right click on a checkbox to make that default, but what you can do is go to compare and edit. Let's go use even step downs, and then you can right click there and go make default. So if you didn't know how to make a tick box default before, that's a sneaky little trick on how you make a tick box default. Let me know in the chat if anyone actually knew about that one. That's a sneaky little one that a lot of people don't know about. So again, I'm going to face the top off. I'm then going to do a 2D adaptive strategy going round. Now, a lot of you know that I tend to use tapered helixes when I can. This is an example of when I can't. Physically, there is not enough room, you can see here, to taper the helix going down into the part. So I have to use straight helixes. It's not the end of the world, it's just not as efficient as a tapered helix. For those of you that don't know, a tapered helix is really good, helps out with swarf evacuation. That is then my 10mm roughing. See, I'm going around there nicely. I've now got a 4mm roughing going round. Let's have a quick look at some of the parameters that I used in here. So I used 100 microns or 0.1mm stock to leave, axial and radial on there. Because the problem you've got, let me just grab, I've made 2 of these and actually made a small mistake on the first one, is I forgot to put the stock to leave on. So what you can see, let's just go to there. This is the first one I made, and hopefully if I get the camera to focus, you can hopefully see these marks. Yeah, I can't get it to focus very well on there, but you can hopefully see those marks there. Definitely see them up there, the marks in the part. That was because when the adaptive pass goes, it like hits the wall all the time when it's doing its passes, and that can cause those little witnesses. And if you don't put the stock to leave on, you actually don't get rid of those. If we now look at the part now, the second one I did, you can hopefully see the much nicer finish going around inside of there. So again, little tip, always use stock to leave on adaptive, never use adaptive as a finishing because you'll get those witness marks where it's hit the wall all the time. Perfect. That was 0.1. I then went to my 4mm, and as you'd expect, I dropped that down ever so slightly. I did not use the same actually. Doesn't really matter too much. I could have dropped that down ever so slightly, or I could have left it the same. I thought I dropped it down, but I hadn't. Oh well. Now let's quickly talk about some parameters that I didn't understand really until I got into Fusion, doing the cam. I come from the inspection side, and I sort of done cam this way. So I sort of had to learn from scratch what all these parameters were. I used to code machines manually. That's how I knew how to use machine tools, because I never was privileged with cam beforehand. I used to have to handwrite everything. You've got roughing step down and fine step down. Now the way I think about this is step down and step up. And sorry if that's confusing, but hopefully it'll make sense in a second. Let's just have a look at that pass, and let's have a look and see what we've got there. So what we've got, we can see that we've stepped down 5mm there. We're going to bring the tool down 5mm, and we're going to machine everything that we can. And what we're then going to do is step up 0.5, that was that finishing or that fine step down. We'll then step back up and finish everything at that layer, step up, finish everything at that layer, step up and finish everything at that layer. Thanks, Akash, I am not showing my Fusion screen. Sorry. Right, let's just go back to Fusion and my camera there. Oh, it's Thursday, everyone. Give me a break. It's been a tough year. I think all I was explaining was the step downs. So edit on here. What we can see is the roughing step down and the fine step down. So that was what we're talking about now. That's that sort of step down, and then there's little step ups that we do. So we've got, let's show you, I'm going to repeat what I was saying, but hopefully you can see it this time. So I've stepped down from this plane down to this plane, machined everything I could, and then stepped back up 0.5 mm, 0.5 mm, 0.5 mm, and you can see I'm just machining more and more of the form as we go. So hopefully that makes sense, the way that in these 3D adaptive passes, you've got that step down and that fine step down. That's how those parameters work. You know, I then go down another 5 mm, and you can see here, it's not actually doing those step ups because it doesn't need to. It's clever enough to know that it doesn't need to do those little 0.5 mm passes back up and back up and back up. Very clever, isn't it? Credit to the developers who write these algorithms. They definitely know what they're doing on these things. But hopefully that makes sense to everyone out there. On the 3D adaptive passes, while you have 2 step down amounts, you've got to think that one of them's like roughing everything out, and then the other one is how, basically, I think of it like a resolution. How much do you want it to go back up and pick out all those tiny little bits? You've got to look at the geometry of your part and then the subsequent operations to work out how you want that to happen. I tipped the part up and did some little contour passes to actually finish this little string holder, and then my favourite toolpath, the Rotary toolpath. So what I've done then is done a rotary toolpath around the part to actually make sure I get a nice finish. So I'm not going to forget the camera. You can see I've got quite a nice finish actually on the edge of this part as we go on there. Some of you might notice that it's not plunging into those Fs. And how have I got it to do that? Well, what I've got it to do is I made this body here. So this was really simple. In the design environment, I did a sketch down the middle. I projected the body and then did a surface, and I did a revolve going around. I could have just as easily done a manufacturing model and done it in there as well. If you haven't tried manufacturing models yet, definitely give them a look. And I created that surface. And what I did then in the rotary toolpath, let's duplicate that. So I don't want to lose what I did originally. And let's see what happens if I turn it off. So this would have been if I just made the toolpath without doing those geometry changes. We'll see how the toolpath looks now. So it's going to calculate that toolpath, and hopefully what we're going to see is it diving into these Fs. Now, that's not going to be good for the tool. It's going to actually cause a lot of undue stress on the machine, because it's going to keep having to try and dip and dive into those Fs as it goes. I mean, we look at there, we can see, you know, it's going to have to come down, make a sharp turn and come back up again. And that's actually going to slow the machine down, because what it's have to do is have to slow down and decelerate into the turn to accelerate out of the turn. Think of toolpaths like driving a race car. If there's a bend, you have to decelerate into the bend and accelerate out of the bend. Machines have to do exactly the same thing. So I didn't want to do that because I was going to finish those later. I wasn't going to finish them with my 6mm ball nose, what I was using for the outside. So what I did was I basically overrode the model that was defined in the setup. So I went model surfaces. I went to the model and I said include the setup model and now add that body as well. And what we've got there now is, let's have a quick look. We've got the toolpath. I'll kill a bit of time. This was the one that was calculated earlier, and we can see there it's not plunging down. So I know you all want to watch the machine run, so I'm going to stop talking and we're going to run this rotary toolpath on the machine. It's by far the most exciting one. So there we go. On the machine now, let's quickly find the right program on here. So that's the rotary pass. Let's quickly bring you all into the machine a little bit closer, and we'll have a look at what we've got so far. So we've done the roughing passes so far on the machine. Let's just bring this in a little bit closer. There we go. So we see we've done the roughing passes on the machine. Now, what we've got is looking a little bit something like that. So I hope that's nice and clear for everyone. We can see we've got the, we can see those step downs on the nose and on the Fs we've got there. So that is effectively what we've got on there. Let's tip this I-axis up a little bit and have a slight more look at the edge of that part. So again, we can now see those fine step downs that we've got on there as well. So we're going to take all those step downs off now with our rotary toolpath. So this actually is a really nice toolpath to watch. It's quite hypnotic. So let's shut those doors. Let's move that camera around a little bit. I'll probably have to change the focus and the zoom once the toolpath gets going, but let's just start this machine up. Again, anyone that knows me knows I start the machines very slowly. If you're going to crash a machine, it's most likely going to be on the first bit where it cuts, where you've got the tool length wrong, or where you've got your work offset wrong, or you've loaded the wrong program in. So I always start nice and slow. Let's turn coolant off. It will unfortunately damage the surface finish, but I would rather you actually see what's going on. And I'll explain why it will have problems with the surface finish in a second, but I'm just concentrating now to make sure I don't smash the machine. There we go. Brilliant. 100% feed rate, and away we go. Let's have a quick look. Let's move that camera up, everyone. Sorry, that was a bit low, but I can only do one thing at once. I can't multitask very well. So we can now see, talking around, doing the rotary. I mean, when I was watching that earlier, I nearly went to sleep watching that those Fs and those antlers go round. So why did I say that it was going to damage the surface finish? Well, cutting aluminium, it's actually very sticky, and it melts very quickly and easily. So if you haven't got coolant on, there's a tendency for the swarf to actually stick back onto the material, and if it has to recut the swarf, because if it's landing in front of its path, it can actually like weld itself to the surface as well there. Coolant just helps wash the swarf away and make sure that's not going to happen. But for this part, I'd much rather that you all get to see the machine running as well as it is. So again, we'll watch that for a few seconds while we're going on there, but hopefully this is, again, a nice indication of what's happening at Rotary toolpath. I've used a spiral rotary here, so it's going to increment over steadily across the part. It's not going to do a full revolution and a step over and another full revolution. It's going to slowly start to spiral across the part. So, hope that's nice for everyone to look at. I know a lot of people out there are thinking they wish they had a machine slightly like this. I definitely wish I had a machine like this in my garage, because I'd never be doing anything else other than doing amazing toolpaths like this. So again, that is the rotary toolpath. This is an example here of, I know I've got a 5-axis machine, so an A and a C. But if you just had one rotary axis, so just had an A, for example, this is exactly what you'd use. So I wonder, could anyone work out what axis we've actually made on our machine by doing this? So by putting the A at 90, what axis does our C become? See if anyone can guess that in the chat. I'll let you know in a second. It's not really a challenge if a lot of you out there know how the machine kinematics work, but could be interesting to some people. So again, see the rotary toolpath's going on there nicely. It's going around that part in that spiral pattern, so it's been working closer and closer to the edge, that back face as we go. So there we're going on there. See the folder toolpath. Yeah, again, I'll have a chat to the guy on Instagram who gave me this file. Check he's happy for it to be shared. If he is happy, then I've got no problem in the toolpaths being shared. There's nothing wrong with that. So let's jump back into Fusion, and I'll let you watch that run for a bit and be a bit hypnotic while you're going on there. So to answer the question, if you turn the A at 90, your C effectively becomes a B axis. So if you had a B axis on the machine, it would be pointing the same way as that one is there, and it would be constantly rotating. For those of you that don't know rotary axes, the machine on the axes on the machine, linear axes are X, Y, Z. Rotary axes are A, B, C. A being about X, B being about Y, and C being about Z. So simple, X, Y, Z, A, B, C. If you rotate 190 degrees, you effectively change, in theory, what axis that is. Nothing changed on the machine. The machine still knows it's a C axis. But if you had just that one mounted on the machine, it would be pretty much like a B axis. I know that was a lot of letters and a lot of axes, but hopefully it all made sense to some people out there. So we can see our rotary toolpath on there. So really nice. It's not going to be diving down into those. It's going to give a really nice consistent surface finish on our part. The next one is I've used steep and shallow. This is an absolute godsend of a toolpath. So what steep and shallow does is it looks at the regions of the part and puts them into two categories. Now, the reason behind this, and I'm going to go really off-piste here, and I'm actually going to use paint, and I'm going to draw some pretty pictures on the screen. This is, this is cutting-edge technology we've got going on here, everyone. So, if we've got a part with a very small angle on it, what we've got here effectively, when we're going to step over on our part, we've got a step over there, and then we've got the step down there. So on places like 2D Contour, we mainly give a step over. So that's using this line here, stepping over, stepping over, stepping over, stepping over, stepping over. But as soon as we go to very steep regions, you can see if I step over the same amount as that, look how much step down I then do. So the step over was the same on both of those parts. It was approximately let's call that 10 mil, let's call that 10 mil, and let's call that 1 mil. So on here we stepped over 10 mil and stepped down 1 mil. On here we stepped over 10 mil and stepped down 100 mil. So you can see why we can't treat steep and shallow regions as the same, because you tend to use step over on shallow and step down on steep. I hope that was clear. Please say if it wasn't, and I'll think of some other way. I didn't plan on using paint to describe that, but I thought I'd just try and show very quickly. So what steep and shallow does is it's got something called a threshold angle in it. And what this threshold angle does is it's essentially going to look at what you define as steep versus shallow. I chose 45 on this because it just worked well with the geometry of this part. And what that's going to do is go, right, at what point does an angle of a face change from being steep to shallow? And what happens then is for steep passes, we use normally something like a contour step down. And then for shallow passes, we can either use scallop or parallel. I'll show you why I use scallop in a second as well. So all it's doing is this is actually applying two toolpaths to our part. It's applying a constant step down contour pass here, and it's applying a scallop toolpath here. So this is like a hybrid toolpath that grabs two toolpaths and applies them to our part. All I did was put the threshold angle, put my step overs, I put my boundary in there, and I hit OK, and it made me that toolpath. Now, yes, this is in the extension. I'm not going to get into arguing over buying the extension or not, but if you're employing programming engineers, the amount of time that has just saved, the extension would have paid for that time. I guarantee you, I could have spent 3 or 4 hours defining all these different regions of why I've got steep toolpaths over shallow toolpaths, and how I would have actually chosen them. I'm just going to quickly, there we go, just machine that part. How lovely was that? We'll look at that part in a second. But just to talk about steep and shallow a bit more, you can see here that it's doing that step down pass going down these steep sidewalls. And then when we get to like the face of the reindeer, it's doing the scallop toolpath. So again, I could have done this myself manually, but it would have taken me quite a while to do that. And then if I just change to a different camera, I'm slowly getting used to everyone about swapping cameras all the time. You can see that the scallop toolpath, because what it does is it takes the model outline and offsets it in. It actually made this really nice pattern on the part, which sort of like, just helps look at the reindeer's face. So again, I just chose that toolpath because I like the way it offsets in from the outline of the part, and I just think it makes a really nice finish on the part then. So that was why I did that. Let's jump back into the machine. Let's have a quick look at what we've got on here now. So let's have a quick look at what the outside profile looks like now. Let's jump in there and let's move this a bit closer towards everyone. I'm actually going to take this off our machine now for you all. Sorry about the noise, everyone. I'll just cover my mic a little bit. Sorry, I hope I haven't just deafened anyone on the call. Right, but what we've got here now, let's take this off just so you can all see what's going on. This is really not good practice to remove a part before you finish machining it, but I'd much rather show everyone what's going on. I'm happy to not have a perfect part at the end of this if it shows someone something to do. So, right, I now need to turn it the opposite way than what I think, because I'm internally clamping, so I need to actually undo the chuck rather than do it up. And what you can see there, you can actually see those jaws that I've got. We can see on here, let me just clean that off again. So you can see here, these are the jaws that I made. So you see these are the outside edges that I cut in Fusion with that contour pass. And you can see here that that's actually been cut away. That jaw has. Here, again, let me try and move the camera here so you can see those jaws a lot. Again, I'm not going to make a career as a videographer or anyone anytime soon, but I'll do my best. So you might be able to see that F that's actually cut into there. If you imagine when this part is on there, you can see that's a witness mark from the machining on there. So people asked me before, how do you program cutting that out? Well, I don't. All I do is I know that if I need to machine jaws like that, I just machine the part, it machines the jaw underneath, and then it's done. So I don't actually model up all these, these tiny little, bits of clearance that I need to put on the jaws. I just machine the part once, and then I know the jaws are being cleared for the next part. It's as simple as that. As long as you're aware of what's going on, that's all that really matters. So you can see I've datumed, of course, off this top face of the jaw, and I datumed off, I've got a little setting ring that I clamped into these jaws to set the center, and then I did that contour pass to machine, and then I've got everything on there. So let's try and locate this back on. I'm just going to have to try and line up those witness marks with the part. Again, I really don't recommend doing this, but those of you that have watched live streams before with me know I spend most of the time doing things that I tell you not to do. I'm a bit like a bad parent. So, perfect. Let's tighten this up. Again, that'll be close enough for us just to finish off a few bits and pieces on the machining side of things. So I'm not going to do the steep and shallow pass on there because it takes 40 minutes, and I definitely don't want to be here for the next 40 minutes, and I'm sure you all don't want to just hear me talk about toolpaths while it's running. So what I'm going to do some interesting ones. We're going to do the outside Fs, the ones that are run around the outside of the part. They look a lot nicer on the machine. So select the right program. Again, I'm going to run this very slowly to start with. We're going to do a tool change. We're going to change to a 3mm ball nose now. And hopefully it should all move into view in a second. So the machine's just reset back to 0. Let's turn that coolant off again. It won't be very good for the part, but it at least means that you can all see what's going on. Right, there we go. Let's go down nice and slowly now. There we go, brilliant. So what I'm doing now is what I would call a 3+2 positional toolpath. People tell me about 3-axis, 4-axis, 5-axis, but quite a few people don't really understand what we mean by all those terms. So when we talk about 3-axis, we can all know about that. It's where the 3 axes are interpolating at the same time. When we talk about 2-axis, like laser cutters, 2 axes are interpolating at the same time. When I say interpolating, I just mean moving at the same time. When we talk about 2.5 axis, you might have heard that talked about before, which is where the X and Y interpolate at the same time, and then the Z is like steps. So the Z will go down to a level, it will then machine, it will then go up a level, it will machine, it will go up a level, it will machine. Creates pyramid type shapes. Talk about 4 axis. That was what we saw just with the rotary toolpath, where 4 axes are all moving at the same time. 5 axis, I haven't got any 5 axes on this part, but you get what I mean. All 5 axes are moving at the same time. What we've got here, though, is 3+2 positional. So we've got the 2 rotary axes have moved into a position. They're now locked, and it's now machining with just 3 axis only. So what you've got here with tool orientation inside of Fusion, this is doing something called 3+2 positional. You can do 3+1 positional as well. If you've got just a 4th axis on your part, on your machine, you can just index that 4th axis and do it that way. So don't get confused when people talk about 4 axis or 3+1 or 3+2. It purely means, if they say 4 axis, in theory, that means that all 4 machine axes are moving simultaneously. So again, thanks very much for everyone watching the live stream. We're going to finish off a few more things, but we haven't got much long left now. So if you've got any questions, now's the time to be hitting them up in the chat. I'm just going to quickly show you the part again because I like the look of it. So we're just going to do it all there again. So again, this was the part that I made. I've made 2 of them so far. First one. Again, we've got all those nice features on the inside, remember. We did the Op10 features first. We then flipped it over, did all the outside features. We then machined the Fs, little 3mm drill hole in the back there, try and hang it on the tree. Again, just a really nice looking part. The other parts out there from the Cam Challenge, let's quickly go back to having a look at those. They were just as good. I really couldn't believe sort of the quality of some of the entries. I mean, I thought I was an alright fusion designer, but I've clearly got a lot to aspire to. This was the one I chose purely because I knew that I could make it with our chuck on the machine, and it had a nice bit of 3+2 positional, 4-axis rotary. That was it. So it was purely just because I knew it would just make a nice demo on the machine, and I could hold it without having to buy any bespoke fixturing. I was going to make the one on the sort of middle right, the F with the triangles, but I couldn't think of an easy way to grip it without having to buy some proper soft jaws in and then machining them to fit. I already had a set of soft jaws on the chuck, so it's as simple as that really. It just made it very easy for me to machine. That's why this one was chosen. But really appreciate everyone that entered. I'll try and run these sorts of things again, these challenges, when we've got different holidays coming up. Just a nice way for us all to share our passion for design and engineering, really. So, the DIY Electros asked the video be saved. All of the live streams are saved, other than one of them, which was a steep and shallow one that went catastrophically wrong with me and Paolo. We let that one sort of fall away. We didn't want to save that one live. That was a special for anyone that tuned in. All of my live streams, all the other live streams we do are all saved. If you just search Fusion 360 Live, then you'll see all the live streams that we do. EL, thanks very much. Yeah, again, thanks very much for tuning in again, EL. I hope you will actually get something out of these live streams, not just watching an Englishman talk about machining for 45 minutes or however long I take, but hopefully giving some people some nice tips and tricks today, especially things that I struggle with, like when I first started looking at what 3D adaptive step over versus fine step over was. It took me a while to get that around my head, how that was working and how I should program it to be used. Again, EL's being a brilliant plug here. Everyone, don't forget to like the video, subscribe, hit the bell icon. I do these every sort of 2 or 3 Thursdays. It's only about 2 o'clock, but I had to push it back this week for another commitment. I try and do them live from here as much as I can, but I can't always. Put in the comments, what do you want to see again? What do you want to see? I know people have asked for a mold tool. The problem with that is just quite difficult to fit into 45 minutes, but I'm thinking of ways we can do that, so don't worry too much. There might be something coming in the new year on there. But brilliant, everyone. I really appreciate your time today. Hope it's been useful. If it's not, say, because we need to make these things useful, or else there's no point in me doing them, never mind you watching them. So really appreciate everyone's time. Stay safe. I'm not doing another live stream now until the new year. I know it's quite sad, but I need some holiday. I definitely do. I'm very tired. I've been yawning throughout the start of this, you might have noticed. So I'll see you all in the new year. Have a brilliant holiday, brilliant new year, and really looking forward to seeing you all again. So thanks very much, everyone. Speak to you all soon, and stay safe.